Hi, in this tutorial we're going to demonstrate how to work with variables and constants in a C++ program. Now our program is going to be a piggy bank where the user is going to be able to enter how many quarters, how many dimes, nickels, and pennies they have in order to display the total that's in the piggy bank. So I have a working sample here that we can test out, and then we're going to build it. So it's first going to ask for the total number of quarters, and then how many dimes, how many nickels, and how many pennies. And then when it's all finished, it's going to again repeat out the values that was entered by the user, and then give us a grand total of what's in the piggy bank, and it's going to be formatted into currency style format. So you can see that in order to get this to work, we're going to be working with variables, because each time this program runs, we'll be able to enter a different value in here. So this is going to change. So when the user types in the number of quarters, that gets assigned to the variable that we're going to create called quarters. And we'll repeat the similar thing so that for dimes, the value that the user enters here will be assigned to the dimes variable. So to get started, I'm going to create a new project in my C++ editor. Okay, so I have just a plain skeleton of a C++ program set up here, where I have the include input-output stream and using namespace standards so that we can use the shorter phraseology of using cout and cin and similar things. I have the main function set up in between opening and closing curly braces. Now your system may not need to use system pause, but if your editor pops open a console and the console disappears automatically without giving you a chance to view the results, then you should add system pause. The editor that I'm using doesn't need this, and it'll actually give me a little bit of an error message if I run this right now. You'll see that down here I'll get a little error message saying pause command not found. So my editor does not need this. So I'm going to just comment it out, but just be aware that the editor that you're using may require it so that you will pause the console to be able to see your results. So now if I run this again, we'll see that we don't have any message that pops up here. So to begin with, I'm going to start by creating some variables that will represent the values for our quarters and dimes and nickels and pennies. I'm going to make them of an int type. Now an int is short for integer, which is a whole number, and I'm using that because I'm not going to have a half of a quarter or a half of a penny. So I'm going to say quarters equals 0, and I'm going to set it equal to 0 at the beginning to establish an initial value and also set that aside in memory. Now I could continue down here and I could repeat this and say int dimes equals 0 and put a nickels on the next line and then pennies on the next line. But since each of these variables that we're using are all going to be of the same integer type, then what I can do is, rather than putting them all on different lines and writing out int each time, I can come back up here and I can separate quarters from dimes and just say dimes equals 0, nickels equals 0, and then pennies equals 0. So I can create and initialize all of these all in the same line all at once without having to put them on different lines. So again, this is going to put this into memory, and it's going to assign a value of 0 to each of those. Now, especially if you're a beginning programmer, you might be saying, well, what about the spacing in here? Do I have to have this space between the word and the equal sign? And the answer is no, that's not a requirement. It's not going to cause a problem in your program. But I think that putting the spaces in here helps to make it more readable. And readability in your programs becomes more and more important as your programs get longer and more complex. Okay, so we have our variables for the number of coins initialized here. And so next, let's set this up to get the number of quarters. So we'll say get number of quarters. And to do that, first of all, we use the CIN, which is short for console input, and the extraction operator. The extraction operator are the two greater than symbols. And then we say console input, we're going to get something from the keyboard and we're going to assign it to our variable. So this is number of quarters. So I'm going to say CIN quarters. And you can see my editor does recognize that I had already created that variable, and it lets me press the tab key in order to do that. You may have an editor that will allow you to do that to make it a little faster for typing. So if I get this part, this is going to stop the keyboard and allow the user to type in the number of quarters. So I'm just going to run that so you can see what happens. And I get a warning message in my editor saying unused variable, dimes, and it's also going to say the same thing for nickels and pennies, and that's because it's just warning me that I've created these variables but I haven't used them anywhere in my program. So when I run this, it is blank. I don't have any message here that says anything about what I'm supposed to do or what it's expecting. And that's because we didn't put any message to the user to tell them what they should be doing. So this is actually pausing here for waiting me to put in a value for the number of quarters, and then my program ends. So it's always useful if you're going to use a CIN to preface it with a cout statement that tells the user what they should be doing. So I'm going to say cout, and we'll say how many quarters, and then I'll put in my semicolon for the end of my statement. So now when I run this, right, it says how many quarters, and it stops here, and it's ready for me to type in some value. And then I press enter, and now that's the end of the program because that's all that we're doing here. So what if I wanted to print out how many quarters the user entered? I can come in and say, I can do another cout statement, and I can just say, I'll put in a text string here that said you entered. I'll put a space in there so that it is spaced out a little bit. My insertion operator and the name of the variable that has the value that I want to display. And I'm just going to put an end line in there so that it will move the cursor down to the next line. So now let me run this. Okay, how many quarters? And I'll say 11. And press enter, and it'll say you entered 11. So we have getting input from the keyboard using CIN. The value that gets typed in this case 11, gets assigned to the variable quarters, and then here it demonstrates how to output our variable along with some text information using a cout statement. So for right now, I'm just going to comment out this cout because we're going to put this together later to say how many they entered. So we'll move that down in a minute. So I'm going to come in here and add in getting the number of dimes and nickels and pennies, and we'll come back and try running this. Okay, so I have continued adding the code in here to be able to get the number of dimes and nickels and pennies. And you can see that it really uses the similar format to quarters. We're using a cout statement to tell them how many dimes, and then we're using cin with our variable name in order to store the user's entry into that variable. And so we just change it for the dimes and then nickels and then pennies. So let me run this so we can test and see what this does now. And you can see that my warning message that I had up here goes away because now I'm using all of the variables that I initialized up here. So we have the number of quarters, right, and when we get to pennies and press enter, then the program ends because that's as far as we've gotten with developing the program. So now let's output each of these other variables so that we can confirm that the values that we're inputting is getting saved into memory. So we started out with one cout statement with the quarters, and I'm going to just continue adding on to that. So you entered blank quarters, and so I'm going to put in the word quarters by using a text string, and I'm going to put a space in there so that there'll be a space between the value of the quarters and the word quarters, and I'll put in a comma. Next we'll tell them how many nickels, so we'll say a space in here. I'm just going to press enter to move down to the next line. My insertion operator and the number of nickel or dimes we'll say. So our variable for dimes, the insertion operator, another text string that will say dimes, another insertion operator to put in nickels, another insertion operator with another text string, press enter to move down here, and then in here we'll put in our variable for pennies, and an insertion operator for another string so that we can say pennies. So we really have one big long cout statement that is piecing together strings, right? So these are exact text strings that will be displayed. So when you see double quotes with text in it, that's going to be a text string. And then the ones that aren't quoted are our variables. All right, so now if I run this, we'll put in some values and we should be able to see the output of what we have. So I'm just going to put in 1 and then 2 and 3 and 4. And we can see that we have 1 quarter, 2 dimes, 3 nickels, and 4 pennies. So next what we want to do is to figure out the totals for each of our coins. So we want to find out the total amount for quarters, the total amount for dimes, total amount for nickels and pennies, and then we'll add them up. So in order to do that, we need some new variables to hold our totals. Let me put in an example of our total, and then we can figure out what type of data it should be holding. So if my variable is called total quarters, and that's going to be set equal to our variable of quarters, and we're going to multiply that times 0.25, which is the value of a quarter. So this is creating a new variable, but we have to give it a data type. Our more commonly used data types that we'll be working with in C++ are ints, which are whole numbers, which is what we did up here when we created a value to hold the number of quarters, dimes, nickels, and pennies. But down here, we're not going to be able to have just whole numbers for quarters, because if we had 5 quarters, our total value would be $1.25. And so that would not be a whole number. So we can't use this as an int. So a couple of options, especially since we're dealing with small decimal places here, would be either a float or a double. So I'm going to make this a float type. And so now we'll be able to use floating decimal places with our total quarters. And then I'm going to repeat this again and make a new variable for total dimes. and that's going to be equal to our variable of dimes, and I'm going to multiply that times 0.10 because a dime is worth 10 cents. And I'm going to repeat that for nickels and pennies. Okay, so now we have our variables in here for the totals, and that will be figuring out the total number of quarters, dimes, nickels, and pennies. So let's see if we can output these totals. So I'm going to copy this cout statement and paste it in here after we have our variables. And instead of you entered, let's just say totals. And instead of just the value for quarters, we want total quarters. And for nickels, we want total nickels. And dimes, we want total dimes. And for pennies, total pennies. So let's run that and see what our totals are looking like. So to keep it simple, let's just put in 2 of everything. 2 quarters, 2 dimes, 2 nickels, and 2 pennies. So we can see the individual values listed here, and then our cents values in here. Right, 2 quarters would be 50 cents, 2 dimes would be 20 cents, 2 nickels would be 10 cents, and 2 pennies would be 2 cents. So then the next thing we have is, let's add all of these up together to get a grand total. So we need a new variable for our grand total, and since it's also not going to be a whole number, then I'm also going to make this a float. We'll say total money, and that's equal to our total quarters plus total dimes plus total nickels plus total pennies. And then we'll do a cout statement that will print out the grand total. So we'll say total in Piggy Bank, and we want it to display our total money variable here. So we'll say total money, and we'll put an end line in here. Okay, so now I'm going to save, and let's run that. So we'll put in some values in here. It shows us our totals in here, and then we have our total in the piggy bank. It would be nice to put this into currency format, so we can put a $sign. So I can put a literal $sign in here to print, and we'll run that. So when we run this now, we can see we have our currency, but it would be nice to be able to show decimal places in here, 4.00. So let's look at one quick technique that we can use to format this out so that we can have 2 decimal places. So we can add, before we output something, we can do a little bit of formatting with this, with our cout. I'm going to say cout, we'll say fixed and set precision. I'm going to set it to 2 decimal places. So now let me run this, and we should be able to see this go from 4 to 4.00. Okay, now I go to run this, and I have an error message popping up. And one of the things that these are called, these fixed and set precision are called manipulators. And in order to be able to use them, we have to include the input-output manipulator header file. So that means we have to go to the top of our program, and like we have the include input-output stream, there is an include, and it's called iomanip. That's for input-output manipulators. And that allows us to have access to these functions to be able to manipulate our output. So now I'm going to run it again, and now we have a succeeded. And so we'll say 4 and 10 and 20 and 100. And now we have a nicely formatted currency format, including 2 decimal places. Now, one other thing that I wanted to highlight in here is the concept of magic numbers. Now, up here where we created these variables to hold our totals, we kind of magically put in 0.25 and 0.10 and 0.05. And we know that these are because this is how much a quarter is worth and this is how much a dime is worth. But in programming terms, this is a magic number, meaning you really have to read through and try to figure out where these values came from, because they just sort of are magically there and they're not seem to be connected to anything. So it's considered good format that when you're going to use something like this, that is going to be a constant value rather than a variable, to create a constant and then use that constant in your formulas. So what I'm going to do is move up to the top of my program where my other variables are defined, and I'm going to create constants that are the values of quarters, dimes, nickels, and pennies. So to create a constant, we use the const keyword. We still have to specify the data type that's being held in the constant. So these are decimals, and so I'm going to stay with the float type. And then I'm going to give the constant a name. So this is quarters. The naming convention for constants is to use uppercase values. And this is true in a lot of different programming languages, so not just C++. And what that does is, to the developer or the programmer, you can automatically see if it's all uppercase, you know that it was a value that's been created as a constant and set up previously in the program. I'm going to set quarters equal to 0.25. And then I'm going to repeat the same thing for dimes and nickels and pennies. So constant float dimes equals, and then this is the 0.10 value, and nickels is 0.05, and then pennies is 0.01. So now anywhere in my program that I want to refer to this value, I can just use quarters, and if I want to refer to nickels for 0.05, I can just use the value nickels. So now I'm going to come back down here and replace this with, instead of 0.25, I want to use my constant value of quarters, and then this is going to be the constant value of dimes, and this one is for nickels, and this one is for pennies. So rather than having magic numbers in here, we have this value that is set up as a constant. Another reason that you might find it useful for constants is that, if you refer to this in several different places in your program and you need to make a change, we can easily come up here and make a change to whatever this value is, and it will automatically be updated everywhere. But in our case, the value of quarters doesn't change, or dimes doesn't change. So let me demonstrate running this one last time, and you will see that it should run the same way. Let's go for some higher amounts. We've got some big savers here, so we'll put in higher amounts. So we have the amounts that were entered, the total for each quarters, dimes, nickels, and pennies, and then the total in our piggy bank. So that's an example of a program that uses variables as well as constants, and then a very brief introduction to formatting the output in here so that we could have 2 digits in our currency output.